Well, welcome back to the hang gliding files. Today we're going to talk about simulated worldwide environments. And in the past, we've talked about a lot of things inside the simulator, like flight dynamics, flight controls, weather, thermals, clouds. But what we're going to talk about today is weather, and weather on a worldwide scale, and how we can get weather simulated within the simulators, how that's done, and what that means when we try to use that weather either in a single person hang gliding, multi-user hang gliding, and this is important in trying to have hang gliding be a fun and nice experience. And the way that we have to do that is that we have to have some variability in what actually happens when we're flying. And the only thing that really changes out of all of that, the glider never changes, flight dynamics never change, flight controls never change. What changes with every flight is the weather. And if we don't have dynamic weather and unpredictable weather, then every time that you go to fly your favorite site with a set weather preset, it becomes predictable. Everything about it is always the same because the weather is being created algorithmically. It's being done by a computer program. It's given a certain set of presets, a certain amount of values, and then it generates an environment from those base values. And no matter how well the environment is simulated, how good the clouds are, how realistic it looks, if it always is exactly the same for the exact same location for the same given set of preset values, it just becomes a game that you just realize what the algorithm is and you learn how to beat it. Hang gliding shouldn't be that. It should be completely unique every time you visit a site, and that means using real weather. So what we're going to do today is I'm going to visit a lot of different sites all over the planet in a way of evaluating how the weather is being simulated in each environment according to the real weather of the exact current date and time that I am doing this recording. Everything you see is done on the same day, in the same time, in this exact sequence that you see in this video. Well, the first thing you're going to see here is I'm going to show you how you get the METAR weather in the simulator. And this is the lowest quality, lowest fidelity weather information that you can get, but it's the thing that is most familiar with most pilots. And now here I'm going to show you what other kinds of things that you can do with weather, and it's mostly just presets, and all different kinds of weather scenario presets can be used, and these set of certain set of conditions, but they're stagnant. They set a beginning starting point of value, and then the algorithm takes over from there. But if you start always with the same preset, you get always the same result. So it's just a matter of understanding what that preset does in your particular location, and it never changes. So not only does weather change, location changes. So we're able to go to anywhere on the planet. Here I'm using our widget to go to any hang glider site on the planet, and every location should have a different set of weather. So using a preset wouldn't work. Here we're using another tool to do a teleportation to an airport. And 90%, 99% of all pilots in the simulators are going to be flying airplanes that fly from airports. And so they want to teleport to an airport. But the key thing here is that as you move around the planet, I'm not changing the time, but the weather has to change based on where I'm at and the time, the season that I am, the hemisphere I'm in, time of day that I am. All of that's important, and a preset won't let that happen. And another very important feature is when before you start a flight, you can pick anywhere on planet Earth that you want to start at, let alone the teleportation. And when you're looking at the planet, you can see a great deal of the Earth is in darkness. And if you're trying to fly with other people in a multiplayer thing, somebody lives in Colorado and I live in Australia, or somebody lives in Europe, different times a day and uh, different time zones. So that has a really big impact on trying to set up where you're going to be able to fly with your friends and where you're going to be able to fly if you're trying to use real weather. And I highly encourage that everything that we do in hang gliding, we use real weather, or one other alternative to real weather is captured historical real weather that can be played back based on both time and location. So it has to come out of some database source so that you could replay what was done in real time in real weather so that it changes as you move and it changes over time. As we're doing this experiment and we're moving ourselves around the planet, we're doing exactly that. We're changing our location and we're changing our time, and we should get different weather every single time. Well, there can be no doubt, really, that Microsoft Flight Simulator does an excellent job in rendering different scenarios. Everywhere I went was different. Clouds looked great. Um, Weather looked different. Um, so their rendering is really good. So we still have a little bit to learn about how they're doing that and how they get the results that they're doing. The other thing to kind of pay attention to when we're doing these um, site reviews, as we're just looking at the weather as we're moving around the planet here, is this is basically how you're going to see the weather from a hang glider. It's not like looking at the weather out of a cockpit. It's you're completely open and exposed, just like this. This is what you would see. The only thing that would be in your peripheral vision would be the control bar and some wires, just overlaid a scene like this, and you can look in all three dimensions and looking around. So this simulates pretty good as to what you could expect to see when you're flying a hang glider in this kind of weather. So keep that in mind as we're going around. One of the things I try to do here is make sure that um, we're rendering what we're going to see relative to what it is that we're trying to do, which is going to be hang gliders. Um, Here we're starting on a runway just so that you can see the weather that's occurring on the ground, but this is how it would look up in the air outside of the cockpit. Well, I'm not sure if it's self-evident yet, but it should be. This is a simulator that I am instantaneously going around the entire planet Earth in basically the exact same time of where I am sitting here in Australia. But everywhere I go, it's a different time zone, it's a different season, a different everything. And the simulator simulates different weather everywhere. And what seems to be accurate weather. That's remains to be seen if it's really accurate, but it sure looks accurate. It definitely looks different, and it looks dynamic, and that's very interesting. But just imagine the not only the computational work to render these different environments, but it understands the context of where it is that you are on the planet and how it renders that information. So that's an enormous amount of data that must be being fed into the simulator at runtime to figure out how to do all of these different weather scenarios. That means it's getting data, and it can't be METAR data because, as we've been showing as we've been going along, the METAR information is either non-existent or extremely sparse in the amount of information that it represents. So to get these kind of results and this kind of difference, you need a tremendous amount of different variables of different kinds of data to get into the simulator engine so that it can render something that's this much different than just out of the box, random, algorithmic generated, weathery looking stuff. This looks like real weather. So there's something going on here. What's interesting here in Darwin, if you look right there, that's actually simulated virga, which is rain touching the ground. Quite cool. All right, and now we come back home. Basically, this is where I live. I live on the beach in the Gold Coast of Australia, and this is basically right over my house. And this is the real simulated weather that the simulator sees from my house, my location, at this exact time. So we'll just fly out to the beach, and then we'll try and compare that to what the actual real weather looks like. And this is what the real weather at that exact same time looks like outside on that same beach. So it's not exactly the same, but it's pretty close. We have about cloud base at about the same level. We have that reported type of overcast, which is not scattered but broken. And so we can see different places where we can see blue sky and didn't see that same blue sky in exactly the same spot. So what the simulator is not doing is not simulating the real weather cloud for cloud. And that's important. What it does is it simulates the type of weather that you're having at a particular location. And that has big ramifications when you're trying to fly with other pilots and we're both trying to see the exact same cloud. So what that means is the algorithm will create the same clouds as long as we both start with exactly the same starting input for the same location and the same time. Okay, now time for some details on how this is all being done. What Microsoft uses is a product called Meteor Blue, and this service provides all kinds of detailed information as an API and for pilots and other kinds of things. And they do that by gathering enormous amounts of data, satellite information, cloud cover like satellites, soundings, weather reports, and they sell this information to people to do with whatever they want to. And here's a really good another page, which is indication of thermals, lapse rates, humidities, clouds, horizontal winds, temperatures, shears. It is complicated to represent thermal dynamics. And here they are, they're providing that with surface conditions, stability indexes, lifted indexes, soaring indexes, lapse rates, humidity. And all of this information is gathered and available based on a given time and location. And this is how Microsoft gets the information that they use to create weather. Well, then the next step is, after you have all of this weather information and data, you needed to be able to do something with it that turns out to look like weather in a three-dimensional simulated environment. And that requires supercomputers and AI. And right now, they're doing it for the entire planet, using this information for a flight simulator. And that is mind-boggling, to be honest. And this is just the beginning. It's going to get much, much more information with much better supercomputers and AI on the back end. Today is not the apex or the epitome of where this technology and this type of thing end up. The lack of historical information in the past is what was made rendering weather in simulated environments impossible. Just think about what people try to do with the climate models. And some research think tank somewhere has got some enormous supercomputer somewhere that tries to simulate out weather into the future to figure out whether climate change is happening or not, or what will happen with climate change. Well, it's that butterfly effect. You need to understand everything that's happening everywhere on the planet and the dynamics of everything as it moves through it, as it goes over time and interacts with itself. Well, that's real weather. And the fact that Microsoft is able to simulate this in a real-time environment is nothing short of miraculous. And other simulators are doing the same thing, which indicates that this information is now available to more people and more programmers and more simulations. Well, I'm going to leave you with one final snippet from kind of a sales presentation from NVIDIA and their Twin Earth project. And as you see some of this video, compare what they're doing with their supercomputers and their artificial intelligence and how they're trying to use that to model climate change and how that looks and is rendered next to what you've just seen in a game, a flight simulator. What we're living in is the age of artificial intelligence reaching into our everyday lives, and it's just starting. And artificial intelligence isn't intelligent on its own. What it is it has the ability to manipulate and render enormous amounts of data into something that is usable, that doesn't have to be programmed. It just needs data and it produces output. And this is going to change the world. If nothing else, it's going to change hang gliding in a simulated environment. So if you like this and you want to see how this all ends up, where we're going to end up going with all this virtual reality hang gliding. Like and subscribe, and I'll try to get out videos as often as I can as we make progress. All right, later.